Hello and welcome back at the Link channel. Today we will do packet tracer where we will configure the host and bilateral protocol. And this is our network and the activity. And the addressing table we will use that to refer for configuration and to do some verifying connectivity. We know that the spanning tree protocol provides loop-free redundancy between switches within a LAN. However, it does not provide redundant default gateways for end-user devices within the network if a gateway router fails. And for this, first hop redundancy protocol provides redundant default gateways for end devices with no additional end-user configuration necessary. By using the first hop redundancy protocol, two or more routers can share the same virtual IP address and MAC address and can act as a single virtual router. Hosts on the network are configured with a shared IP address as their default gateway. Here, in this packet tracer, we will configure Cisco Hot Standby Router Protocol, which is a version of First Hop Redundancy Protocol. When we configure this protocol on router 1 and 3, those routers serve as the default gateway for the host on LAN 1 and LAN 2, we will create a virtual gateway that uses the same default gateway address for hosts in both LANs. If one gateway router becomes unavailable, the second router will take over using the same default gateway address that was used by the first router. And because the hosts of the LANs are configured with the IP address of the virtual gateway as the default gateway, the host will regain a connectivity to remote networks after host and router protocol activates the remaining router. Which means that by configuring the host and router protocol to provide these redundant default gateways for devices on both LAN, we will do even some testing and for configuration to verify if the configuration are okay and if the host will be able to use the redundant default gateways if the current gateway device becomes unavailable, which means that we have to configure the host standby router protocol active, standby router, and do last step, we'll do some testing. Before we go and configure the host standby router protocol, let's see how the network operate for when both LANs have configured their physical default gateway, which will be the IP address of the interface for the router that is connected with that particular LAN. Which means that for PCA, the default gateway will be the default gateway of the router 1 at the interface giga01, and for the PCB, which shows all end devices for LAN 2, the default gateway is the gateway of the interface giga00 for router 3. And let's test the connectivity and see if the devices will reach the server from both LANs. And since we want to check which route the packets will follow for reaching the destination, the server in this case, we will use the tracert command, which means that we will go to PCA, the desktop, command prompt, tracert 209.200. What you say? And let's show the addressing table here. And as you can see, they go through the router 1, interface giga01. They reach the router 2 through interface giga00. They go to the iNet, which is a router of the internet cloud and cannot be accessed. And then they reach the destination. Let's go to the PCB, desktop, command prompt, search 209.165.200.36. Let's show the addressing table. and see the route. So they go first at the router 3 through interface giga 00. They reach router 2 through interface giga 00, then inet, and then they reach the server. But what happens if one of the links fail? For example, what happens if the link between PC switch 1 and router 1 fails? Will the devices here be able to reach the server? Or if this link here between router 3 and switch 3 fail, will the devices be able to reach the server? So let's delete here in packet tracer. The easiest part is deleting this link, which means the link doesn't exist anymore. And let's go to the PCB and say it sends 4 packets for each destination, and for all those packets we have a request timeout, which means that devices from here are not able to reach the server because their default gateway is down. It does. Okay, let's do the connection here. Let's wait for both sides of the link to be green and check again the test connectivity. It takes time. Okay. Let's use the tracer command. We will show the same route. Now let's go and configure the host and router protocol active and the standby router. First, we will go through the router 1. At the router 1, the first thing we need to do, we have to go to the interface that is connected with our LAN. So, enable, go to global configuration mode, we go to the interface giga 0/1. And after we go to this interface, we make sure that we have configured the latest version of host and router protocol, which is version 2. After we configure the version, let's configure the IP address, which will be the IP address of the virtual default gateway. This address must be configured then in any host that requires the service of this default gateway. It will replace the physical interface address of the routers that have been previously configured on the host. See, we can create multiple instances of host and router protocol on a router. We must specify the host and router protocol group number to identify the virtual interface between routers in a host and router protocol group. This number then must be consistent between the routers in the same group. Here in this packet tracer, in this activity, the group number will be set as 1. So by using standby command followed with the group number and with the IP command, we will configure the IP address of the virtual router, which will be the default gateway. We can see even in activity here, which is the 192.168.1.254 for the virtual interface of the virtual host and router protocol router. So these are now the host and router protocol. It's changing states. If you remember the states of this router, how they go from after you activate the host and router protocol. here in the command line, as you can see, it goes from first state is initiated, then goes from speak to standby, and from standby to active. To designate the active router for host of standby router protocol group, which is the router that will be used as the gateway device unless it fails or the path to it becomes inactive or unusable, we need to specify the priority for the router interface. The default priority in the routers is 100. A higher value of this priority will determine which router is the active router, and if the priorities on the routers for this group are the same, then the router with the highest configured IP address will become the active router. So by using the command standby followed with the group number and priority as 150 in this case, we are manually configuring the priority of this router as 150, which is higher than 100. And now router 1 will operate as the active router, and the traffic from the two LANs will use it as a default gateway. And if it is desirable that the active router to resume that role when it becomes available again, we have to configure the preempt service of the standby router. With this, the active router will take over the gateway role when it becomes operable again after a failure. So by using the standby followed with the group number and the preempt command, we are making sure that the router will gain the status as active router after a failure when he becomes available again in the network. Now let's go and do some configuration at the router 3. At the router 3, we will go the same. We will go to the interface that is connected with the network 2. As you remember, it was interface giga 0/1. Sorry. Let's see, exit. I think it was giga 0. Sorry. I need to recall activity. It was interface giga 00. Okay. Go here. Everything is giga 00. And here, standby version 2, we configure the latest version. And with the standby followed with the group number, which will be 1, because they are part of the same host and router protocol group number, followed with IP, it will be 192.168.1.4. Okay. And let's see the states that this router will go from initiating. And he will go, I think, at the standby. After we do the configuration, let's do some verification about the host and router protocol. So we go to the router 1 by using the show standby. With this, we verify the value for host and router protocol role, group, virtual IP address of the gateway, preemption, priority, and we can also identify the active standby router and the IP addresses of this group. So it means that this is part of the host and router protocol at the interface giga 01. It's part of the group 1 with the latest version. His state is active. The virtual IP address and the MAC address for this virtual router. Preemption is manually configured, that's why it's enabled. This is an active router, and the standby router is the router with this IP address. priority is 150, which means that is manually configured. Now let's go to router 3. Another router 3, we use show standby. Right. Okay. It's part of the host and router protocol group 1, version 2 with the through the interface Giga 0. The role of this is as a standby router, which is like a backup route after the um, active router fails or become unavailable. This is the virtual IP address, which as you can see is the same with the virtual IP address at the router 1 because they are part of the same virtual router. The active router is the router with this physical IP address for the interface Giga 01. Preemption is not configured, that's why it's disabled. And the priority is 100, which means that it's not manually configured. Which means that this priority is less than this priority, and that's why router 1 is inactive and router 2 is in passive mode. And by using the command show standby brief, we are able to see the host and router protocol summary status. It's part of the host and router protocol group 1 through the interface Giga 01. Preemption is 150, which means it's higher than the default. It's manually configured. Preemption is configured. The state is active. Standby router is the router with this IP address, and this is the virtual IP address of the virtual router. Let's do even here, show standby brief. These are the statics. As you can see, this is with interface Giga 01, it's part of the group 1. Preemption priority is 100, which means it's the default. Preemption is not configured. The state is standby. This is the active router. The active router is the router with this IP address, and we are checking this. That's why it's local standby, which means that we are checking the standby router, and this is the virtual IP address. As you can see, it's the same. Now let's do some. Before we do some verification, the first thing that we need to do is to go to the devices now and configure the new default gateway, which is the default gateway of the virtual router. Here. Or we go to the switch 1. Enable config terminal. And with the IP default gateway 192.160.5, sorry, dot 1.2. Okay, exit. Let's go to switch 3. Same. Even here we have to configure the default gateway. Global configuration IP default gateway 192.168.1. Exit. And let's see. Let's go to PC8. Let's go to the command prompt. Let's use the tracer command. Let's see which route they will. So it's the same one. Information go through router 1, router 2, INET and then reach the destination. Let's see the PCB. Let's see. Oh, look. They are following the same route as devices on the LAN 1 because the router 1 is the active router. They are using the same virtual IP default gateway, and the 192.168.1.1 is the physical gateway of the path that the packets from both networks will use to reach the server. So what happened if this link fails? So what happened if router 1 becomes unavailable? The easiest part is delete this link, which means it doesn't exist. What happened with the packets? Let's go to PCA, PCB, and for both, let's say trust. Oh, as you can see now, for both they are going through router 3. Well, since I did them at the same time, it's the network is okay. Let's do that one again. Let's do this. And then let's go here. So it looks like they followed the same path because the router 1 now is unavailable. But let's go and see with the router 1, let's use, it gave information that says that it's full down because it detached the connection from 4 giga Ethernet with the switch. So let's use the show standby. What information? Look, it said the state is initiated because the interface is down. And at the router 3, see, he got the same information here. He said that the link here failed, so you have to be the one that will gain the lead to send the package, which means that don't stay in standby, but go in the active mode and send the package to read the destination. See, it goes to the active mode. So now let's reconnect. Switch one with router 1 and see what happens. Let's take time to both sides of the links to be green. And since we have configured the preemption will make sure that the router 1 after becomes available in the network to gain the status as active router. But when he gains the status as active router, what happened with the router number 3? So first, let's go PCA. Okay, let's go to the PCA and PCB. Come on. And let's say transact. Let's see which route it will follow. I follow the same as was before at the router 1. So it means that the router 1 now is again the active router. Let's see. Let's go to router 1. Yeah, it's inactive now. And let's go to router 3. It's in standby. So that's how the host and router protocol helps network with redundant links to make sure that the information will reach the destination even if the network have failures. So, because the host on the LANs are configured with the IP address of the virtual gateway as a default gateway, and they always will have connectivity to remote networks because of those redundant links and because the host standby router protocol activates the standby routers to send the information to the destination. And we saw even how the active router took the lead as active after he failed in the network and became available again. So that's it all about the practice in the packet tracer for host and by router protocols as a version of first hop redundancy protocol. If you like the video, share it with your friend. Do not forget to subscribe with our channel if you are new. And a question for you is, what happened with the router 1 if the preemption wasn't configured there in this router? After we disconnect the link between switch 1 and router 1, and the router 1 will become available again with reconnecting the link between switch and router 1. Will the router 1 stay as a standby router, or will he gain the status as active? But remember, the preemption is not configured. If you do this test, write down as a comment with your answer. See you till the next time.